Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode weekly contest 433, problem number C, and the problem is maximum frequency after subarray operation. And in this problem, we have to given a nums array and the length of n, and you are also given an integer k, and you perform the following operation on nums, and these are our operations. And after that we have to find the maximum frequency of the value of k after the operations. And now we have to given a definition of subarray. Subarray is a contiguous non-empty sequence of the element. And now let's discuss their example test cases, and then we have to look their coding implementation part. So now here we have to given a nums and with n, and we have to given an integer of k, and after this we have to give it an operation, and this is our subarray. And their range like 0 to 0 less than is equal to I to 0 less than is equal to j. And then we have to select the integer of x and add x to all element in nums in the range of I to j. And so we have to find x, like select the x and add x to all element of the subarray. And now after we have to find their maximum frequency of integer k, and of after performing the operation. And our goal is to determine the maximum number of times k can appear in the array after performing the described operation. And now let's look at their constraint. So here we have to given 10 to the power 5, and the nums is less than is equal to 50 and k less than is equal to 50. So the given constraint are very low, and we cannot use brute force solution like O of n square we cannot use. And so we have to reduce like O of n solution so that we can get our answer correctly. And now let's look at their example test case so that you can understand how we can performing with their nums with their k value. And so first we have to given this nums is 1 2 3 4 5 and 6, and we have to given k is equal to 1. And now initial count of k is 1, and we have to start from how many times k1 appears in our original nums. So now let's look at their case. Like first we have k is equal to 1 is also given here. So now first the second step is we have to modify the subarray. And now this modify the subarray, we have to increase the frequency of k is equal to 1. And now we have to modify the subarray. We can choose from the nums of I to j, and we have to add the same value of x, okay, same value of x to every element in the subarray to make more elements equal to k, okay. And so now let's look at there how we can achieve this one. So first we have the k is equal to 1, and the first value is also be the nums of 0. This nums of 0 is also be 1. So now we have to start from the nums of 2 to 5, okay. This 2 to 5 we have their values are, one second, the nums of 2 to 5, the values are here 3, 4, 5 and 6. And now this nums 1 is our nums 1 is 2. And now the find the value to add, like we have to add the values and we have to get their answer. So now we want to make these elements equal to 1, okay, because k is equal to 1, so that we have to create a values from k to k is equal to 1 from our original array. This is our nums original array. So now the values are, we need to add this 2, okay, this 2. But how, what this form, if we add this 2 normally, okay, this 2 add normally, like we have to increase our values. So let's suppose we have to add 3 plus 2 5, 4 plus 2 is equal to 6, and so on. So we have to increase the values. We have not getting our this k is equal to 1 value, so that's why we have here minus 2, because we have decreased our values so that we can find this 1 in our original array. So after this 3 minus 2, like 3 plus minus 2 and 4 plus minus 2, 5 plus minus 2 and 6 plus minus 2, and so the value of this one is 1, this is 2, this is 3, this is 4. So now our modified subarray becomes modified subarrays 1, 2, 3 and 4, okay. And after replace all the values from our original array, what we have to get here, our original is 1 2 3 4 1 2 3 4 5 6, I guess, yeah, 1 2 3 4 and 5 and 6. And now after modification we have to get here 1 2 1 2 3 and 4. So now this is our modified subarray, and the count of k is 1. And after these operation, what we have our count, first we have the count of k of 1 in our original array is 1, because here 1 is already present, so count is 1. And then after modified this, here what the count of 1 and 2, so count of this one is count is equal to 2. So we have to get our actual answer, this one. So after this, the key point we have to remember, like the first is we have to choose the subarray where adding or subtracting the value to maximize the frequency of k. And in case we have to adding minus 2 of our original array successfully, then we have to increase the count to 1 to 2, so that we can get our answer. So now same thing, we have to look their example second test case, so that you can understand how actually we have to work with their values and how we can achieve their values. So now this one, so we have to given nums is 10 2 3 4 5 5 4 3 2 and 2, and k is equal to 10. And now so first we have, our goal is we have to achieve this 10 in our original nums array and after their modifications. And now here we have the initial frequency of this one is 10, and in here we have also be a 10 present here, and we have to count how many tens are in this nums array after modification. and now initial frequency is equal to 10, and nums contain 1 to 10 occurrences. And now after subarray modification, what we have to getting here, like here we have 10 minus 2 is equal to 8. Okay, and so here we have to start from our 1 to 9. Okay, so 1 to 9 we have their values 2 3 4 5 5 4 3 and 2 3 4 5. Okay, 4 5 3 and 2 and 2. And now we have the value of x is equal to 8. Okay, now x is equal to 8, we have to calculate their values. So x is equal to 8, here we have increase our value, because we cannot decrease our value after 8. If we have to decrease our value, we cannot achieve this 10, so that's why we have to increase. So here after modification we have there 2 plus 8, 3 plus 8, 4 plus 8, 5 plus 8, and again 5 plus 8, 4, again 4 plus 8, and so on. We have to add with these values. So now our modification array is 10, 11, 12, 13, and again we have 13, again 12, 11, and this 10 and 10. Okay, so we have to getting our modification array, and after that we have applying our modification with this actual nums array, and we have assigning their values here. So here we have 10, we have to start from this one, so we have to add this modification to this one. So initial is same, and this is our values 10, 11, 12, 13, 13, and then 12, 11, 10, and 10. Okay, and after this, after all these values, what we have to get here, we have to get this 10, 10, this 10, and 10. How many 10 are present on this one? 1, 2, 3, and 4. And one thing you have to take care, our count is initially 0, but here we have to get our k is equal to 10. So the in our nums, so the count is 1, and the count remains here is count is equal to 1, and now count is equal to 2, count is equal to 3, and count is equal to 4. So our answer is 4. So I hope you understand the example test cases, and there how we can update the values of nums and how we modify their values for the actual nums array. And also you have to take care, like where you have to subtract and where you have to add the values, and so that you can easily find their nums with their k operations. And so now let's look at their coding implementation part, so that you can easily understand what we have to do here. And first we have to count this count of we have to calculate the count of occurrences with k, and after k we have there this loop, we have to iterate with less than is equal to 50 for the given constraint, and after that we have I is equal to k. If this already present on our nums array, then we have to continue to iterate with other values. Okay, and now this s and l is our, this s is equal to our sum, and this l is equal to our max length, and after this we have to iterate a for loop. And now here we have if this one, if I is equal to it, and we have to increment s if value is match, and same thing for here, if else if of it is equal to is equal to k, like we have to decrement s if the value matches with k, and we have to decrement s minus minus. And same thing for this one, if s less than is equal to, if s less than is equal to 0, we have to reset our values, and after reset we have to like reset s if becomes it is a negative value. Okay, and now we have to update the maximum. L is equal to max of l comma s. This basically update the maximum length, and here we have to update the frequency. And one thing, the first max of this one is we have to update the length, and this second max of, and this basically update the frequency. And after that we have to return the initial count of k with max frequency, like this one. Okay, so our initial count is 0, and sorry, initial count is 1, and after modification our count is 3, and we have to add this one. 1 plus 3 is equal to 4, and like here 1 2 and 3. And I hope you understand how we actually calculate the value of, how we can decrement, how we can increment their values. And now let's discuss their complexity analysis. And first we have their time complexity. The time complexity of this code is, first we have to run O of 50 times a loop, and with this is a fixed number of values with the range of 1 to 50. And in this here we have a inner loop of O of n time, which iterate the array. And so total time complexity of this code is O of 50 into n, and so we have the total time complexity of O of n because this is a constant value. And now let's discuss their space complexity. So space complexity of this code is O of 1 because we have no additional data to use, like we cannot use any vector, any set, and so on. So that's why the space complexity of this code is O of 1. So I hope you understand the logic and the implementation part of this problem, like how we iterate the values, and how we calculate with their k values. So thank you everyone, thank you so much.